Hello everyone, it's really nice to present our work on context-aware multimodal pre-training, which was done in collaboration with some amazing people. The primary objective of this particular work is to augment the current kind of vision encoder pre-training workhorse, which is just contrastive multimodal pre-training, generally on image caption pre-training datasets like Lion, Webley, using various contrastive language image pre-training objectives such as SIGLib or CLIP in order to get like a high quality zero-shot generalizable encoder, for example, for open vocabulary classification, retrieval, just kind of a general starting point for further fine-tuning. Now, what we care about is moving this type of pre-training to the more modern era, meaning that beyond just your standard pre-training objectives, we want to add to it the ability to facilitate representation reuse. So scenarios where representations of data are used for downstream complex applications, for example, retrieval augmentation, memory augmented models, all the way to just providing vision context in multimodal language models. And the key perspective in making this work and making this pre-trainable objective is to realize that a lot of reuse scenarios, from few shot to many shot to multimodal language models, generally involve some sort of dictionary lookup, be it soft in the case of attention or hard for really any few or many shot classification model, for example. And the goal of this work is to show that you can actually pre-train vision encoders while maintaining all of the standard CLIP benefits, but add to it much better improved reusability of representations for dictionary lookup reuse scenarios. And I just want to kind of reiterate that the importance of this really is to avoid a trade-off where you reduce zero-shot capabilities just for the sake of adding dictionary lookup capabilities. And so the way we approach this is we take the standard pre-training objective, in this case, SIGLib loss, and we just add to it what can be clearly seen, an additional surrogate objective that operates on the same basic loss function, but introduces two variations. Contextualized representations, so that's the capital X with CTX noted on top, and additionally learnable temperatures. The big T is just kind of the text representation of the text encoder. And so to make this work, we want to introduce something that mimics soft dictionary lookup. And this is the very generalized formulation where we reformulate representations as a contextualized lookup given the original input representation xi over some key and value memory. Now the difficult part is that this is a very overloaded definition and it allows for a lot of different variations on how to populate and design these memories. And through a lot of kind of trial and error, you can find that the best solution is also the simplest because it's also the most scalable, where the key and the value memory are populated by the same representation batch that we already use for the base loss. Now there's two things that are different, which is the inclusion of a mask that masks out the diagonal to avoid a self-attention shortcut for the contextualized loss, and in green for the value representations to use the unused degree of freedom, which is the norm, to parameterize a form of learnable reward signal to better separate out your standard pre-training and the contextualized pre-training. And put together, this gives you a super scalable extension, which adds marginal overhead at best, but some things do need to be taken into account to make it work. One is the use of 3 separately learnable and exponentially formulated temperatures, such that these losses and objectives can trade off really well during training, and the realization that the ability to reuse context is something that we found to be fairly emergent during training. So you need to train for long enough with sufficient warm-up to have models exhibit this capability on top of their base zero-shot performances. And finally, of course, for contextualization during training to mean anything, you need large enough batch sizes. And in the paper, we have a ton of other explorations into what works and what really doesn't work to make context-aware multimodal pre-training an actual thing. But if you do it successfully, you can kind of see that across all forms of reuse of representations, across model sizes and across data scales, we get significant improvements in this case, for example, few-shot representation reuse scenarios. And this scales up significantly to the point where you can kind of 4x the representation sample efficiency compared to your basic objective. You can outperform much more complex reuse-based classification methods, for example, by just pre-training correctly and using the simplest possible model that operates on top of these representations. And on top of this, especially when you reuse a lot of representations, for example, in large context scenarios, this is where contextualized pre-training really shines. And finally, it turns out you can also inject context reusability post-training as well, assuming you do post-train sufficiently long enough. Put it all together, we introduce in this paper a way to inject representation reusability as a pre-training objective, and in a way that is highly scalable, does not trade off based generalization capabilities of the vision encoder, and is simple and easy to use and inject into really any pre-training objective.